Welcome, everyone. Thank you so much for joining us today. I'm Kelly Pirtle with NOAA Communications based in Norman, Oklahoma, and I'm also a member of NOAA's Central Region Collaboration Team. I'll be your host for today's webinar. We are so excited to kick off our 10th 3-minute thesis webinar. Today's webinar is focused on extreme heat. The NOAA Central and West Regional Collaboration Teams have worked together to bring you the latest information about NOAA's work on this topic. From national and local efforts to build awareness and mitigate the effects of extreme heat, to innovative terrestrial and marine research, you will hear straight from the experts on a wide array of heat-related topics. Each of today's panelists will have 3 minutes and 1 slide to cover their topic. This format is based on a model used by universities across the country as a way to briefly share information about a project, initiative, or research. You can see from the outline, after each group, we will take a break for questions from you, our audience. And near the end of the hour, all of the panelists will return to respond to your questions for a few minutes. At any point during the presentations, please submit your questions in writing using the questions pane of the GoToWebinar panel. Nicole Fernandez, the acting coordinator for the NOAA West Regional Collaboration Team, will be taking your questions and sharing them with our presenters. We are recording today's webinar, and it will be posted next week on our homepage, www.noaa.gov/centralregion. At the end, we'd really love to get your feedback on this event. Please take a moment at the conclusion of today's webinar to complete a very brief survey. All right, let's begin. We're going to start with an overview of the national heat tools and messaging used by NOAA's National Weather Service, presented by Kim McMahon. As the Public Weather Services Program Manager for the National Weather Service, she guides national policy involving extreme temperatures, both heat and cold, wind, frost and freeze, fog, dust, and other weather phenomena. She is a co-chair on the White House Extreme Heat Interagency Working Group and a lead on the NOAA and Centers for Disease Control co-founded National Integrated Heat Health Information System, or NIHHIS. Kim, take it away.
Thanks for the introduction. The impacts from extreme heat vary widely due to personal health, activity level, and individual's exposure, as well as other factors. The Weather Service has 3 heat stress to communicate the impact that heat can have on the human body. Each of these indicators are seen as specific tools in the complete toolbox to message the risks associated with heat. Let's start with our first tool, Heat Index. This is the National Weather Service flagship heat tool. It originated from Robert Stedman's research in the 1970s, which aimed to measure the combination of temperature and humidity effects on the human body. The Weather Service simplified Stedman's equations in the late 1970s to use constants representing metabolic rate, body mass and height, clothing, physical activity, and other parameters. The main weather variables are temperature and relative humidity and provide context for the general public on how hot it feels. The next tool, wet bulb globe temperature, was developed in the 1950s by the US military to address high numbers of heat illnesses occurring at their training camps. It's designed for those who are acclimated to working outdoors with high physical activity levels. In addition to the temperature and humidity that Heat Index uses, wet bulb globe temperature also takes into account solar radiation and wind speed. The Weather Service's wet bulb globe temperature forecasts are placed in different colored categories based on the work from Grunstein, noting different areas of the country having different thresholds based on climatology. Lastly, the prototype heat risk, which is currently being generated across much of the Western United States, considers how significantly above normal the temperatures are, the time of year, the duration of the unusual heat, and approximates the influence from humidity. It also has different colored risk categories to indicate how climatologically unusual the heat is, with context of health impacts from CDC data. Each of these tools provide different information and are targeted toward different populations based on stakeholder needs. Having these tools is only one piece of the puzzle to help protect lives. We work with our partners at the federal, state, and local levels to message the dangers of heat. We've recently collaborated within the National Integrated Heat Health Information System and White House Extreme Heat Interagency Working Group to hold a joint social media campaign for National Heat Safety Week. We also developed co-branded informational and educational materials to ensure we're using the same terminology across disciplines and have the latest medical information and terms. The Weather Service continues to work on improving our messaging and education about the effects of extreme heat on our seasonal safety campaigns, building awareness on vulnerable populations, and collaborating on call to actions with partners like OSHA. Providing accurate, reliable forecasts with context, combined with appropriate, effective messaging, can result in a nation that is ready when it comes to heat. Thank you.
Thank you, Kim. That was a great start. Next, we're going to hear about who is affected by heat. Jared Rennie is originally from New England and received both his Bachelor and Master of Science degrees in meteorology from Plymouth State University in Plymouth, New Hampshire. In 2010, he joined the North Carolina Institute for Climate Studies and worked alongside federal employees at NOAA's National Centers for Environmental Information. His work included climate research and visualizations and coordinating with many groups, including FEMA, CDC, and the Society of Actuaries. Just last year, he became a member of the NCEI federal workforce, working to bridge the gap between climate and socioeconomic data. Go ahead, Jared.
Well, thank you so much for having me here today. What you're looking at is a map of the United States. Now, looking at this map, you're probably asking yourself two questions. First question is, what exactly am I looking at? So this is data that's produced by NOAA's National Centers for Environmental Information using temperature data for the first 5 months of 2022 and comparing it against its period of record. Now that you know what the map is, the second question you're probably asking is, all right, cool, why should I care? Well, that is a good question. Now, if I told you that the US is about 1.7 degrees above average, does that help? Probably not. If I also told you that this was the 24th warmest on record, would that help? Also, probably not. Some of you might be looking at this map and also wondering, well, none of these counties are actually their warmest, and very few are in the top 10 warmest. And in fact, some cases, some counties are blue, which means they're actually in the bottom 10, so coolest. So when we talk about extreme heat using this map, why should I care? And that's a good question to ask. And here at NCI, we're trying to answer that by using socioeconomic data from the Census Bureau and others to try to contextualize extreme heat with this data to show that people can still be affected by heat even if it's not a record-breaking month. So as we transition to the next slide, this is just one small example of using this socioeconomic data. So what you're seeing now is a lot of white, but there's some red, some hot spots in the Southeast US. This is showing us two things. It's showing us counties in the US that have an above normal rank so far this year, the first 5 months. Also, it's showing counties that have more than 50% Black population. So as we know, members of the BIPOC community, Black, Indigenous, people of color, they're more vulnerable to heat extremes for reasons such as lack of access to healthcare, lack of access to air conditioning, or maybe not near a cooling center, and many, many other reasons. So this is one way we can show that even though it wasn't a record-breaking month or a record-breaking year, that people can still be affected by extreme heat. And we can slice and dice this different ways using different data as well. We could show the elderly, children under 5, or people with heat-related illnesses like respiratory issues. That is just one way we can show that people are affected by heat. And as we transition to the last slide, you may have heard that I've only talked about the first 5 months of the year. June was and has been an exceptionally warm month for parts of the Southeast and the upper Midwest. And again, using the same data, climate data from NCEI, socioeconomic data from places like the Census Bureau and the CDC and others, we can show that It may not be in the top 10 or the top 5, but people are still affected by heat. Thank you.
Thank you, Jared. One of the reasons we chose the topic of extreme heat for our 3-minute thesis series is because heat events can be so dangerous to our health and even fatal. Better information can help reduce the risks. Our next presenter is Morgan Szabo, the Climate and Health Communications and Outreach Coordinator in NOAA's Climate Program Office. Since last July, Morgan has worked on the National Integrated Heat Health Information System, as well as on NOAA's One Health efforts. She was responsible for the planning and execution of the NIHHIS National Meeting this past April, co-leads the NIHHIS Interagency Communications Group, and is part of NOAA's Extreme Heat Risk Initiative team. Morgan will share with us more information about NIHHIS. Morgan?
Thanks so much, Kelly. It's a pleasure to be speaking with you all today. Extreme heat has been the greatest weather-related cause of death in the United States for the past 30 years, and increasing summer temperatures put citizens at higher risk of heat-related illness or death. Additionally, not everyone experiences heat the same, as extreme heat disproportionately impacts children under 5, older adults, people experiencing homelessness, and many more overburdened and overlooked populations. It is important to remember, however, that heat-related impacts are preventable with proper planning, education, and action. For many years, many federal agencies worked separately on components of extreme heat. So to better serve the American people on this issue and provide a coordinated federal response, NOAA and CDC launched the National Integrated Heat Health Information System, NIHHIS, in 2015 to develop and provide actionable science-based information to help protect the nation from heat. NIHHIS spans many agency missions and mandates to deliver solutions faster and more efficiently, and you can see a list of our partner agencies at the bottom of the slide. NIHHIS consists of an interagency working group as well as partner network that allows us to engage with state, local, tribal, NGO, academic partners, and international partnerships. NIHHIS is also a functioning body of the White House Interagency Working Group on Extreme Heat, where Dr. Spinrad serves as one of the principals. NOAA serves a large role within NIHHIS beyond being a co-lead in housing the program, and there are 6 key functions of NIHHIS, where NOAA is present in all 6. The first one, defining demand, is the most fundamental piece. NIHHIS finds out what decision makers need at what timescale and works together with decision makers to develop the right information. A major example of this was the first NIHHIS national meeting this past spring, where we invited stakeholders and communities together to learn from each other about what's needed to address heat. The second, improve observations and predictions. Based on user needs, the NIHHIS network seeks to integrate and enhance climate, weather, health, and other science-based information to inform decisions with timely, usable, and reliable decision support for reducing heat health risks at all timescales. The third is to enhance research with solutions. NIHHIS coordinates interdisciplinary research, conducts pilot projects, and builds relationships across expert domains to inform community decisions to mitigate heat risk. The fourth is to co-develop products and tools across timescales to provide information to the nation. And the image here on the bottom left is a snapshot of the Heat and Health Tracker operationalized at the CDC, which integrates environment and health information. The fifth, support planning and response. And an example presented here is that NIHHIS worked with the new HHS Office of Climate Change and Health Equity to develop a first of its kind heat outlook, combining climate and health information from NOAA and CDC to support heat planning, preparedness, and response. And finally, the last focus area is to communicate and build capacity. Extreme heat is a silent killer, and communicating the risk of this national problem is imperative. The NIHHIS Interagency Communications Group has developed heat infographics and coordinated federal heat season awareness campaigns to better reach the heat vulnerable public. And in closing, I want to remind everyone that heat-related impacts are preventable with planning, education, and action, and NIHHIS is working towards this to see a nation free from heat-related illness and death. Thank you.
Thank you, Morgan. Yeah, it's such important work. Thank you for sharing. We will now take a few minutes to address some questions. You can type your questions in the questions pane of the GoToWebinar control panel. Nicole is helping us with questions. Nicole?
Thank you, Kelly, and to all of our panelists for their excellent presentations to help us understand some of the fundamental risks of extreme heat to people. So one of our questions is, what do you find to be the greatest challenges when it comes to messaging the dangers of heat? And that sounds like it might be a good question for you, Kim, and maybe Morgan as well.
Thanks. I'll start us off. Heat impacts everyone. The part that I think makes it most challenging is everyone needs to recognize that they are at risk from extreme heat, even if they are young and healthy. If they go running outside on a hot day, it isn't impossible for them to become dehydrated or start to experience heat cramps or heat exhaustion, and which can both lead to heat stroke, which unfortunately is fatal. So it's really getting to reach to every person and have them recognize their vulnerability, and then being able to understand the different historically underserved and vulnerable communities out there and how we can reach them. I'll pass it over to Morgan.
Yeah, to add on to that, I think too, one of the biggest issues is extreme heat isn't like other weather events like a hurricane or a tornado. We're not going to see the huge destruction like with those events. And so heat is called the silent killer. And so being able to really address heat in that way and expand on the amount of people that die each year from heat is important.
Thanks, Kim and Morgan. We do have a couple questions in the chat. Is there a public access source for some of the tabular data regarding the heat tools and the affected people? Maybe that's a good question for you, Jared.
Yeah, so the data that I showed in my talk, the climate data, that's publicly available. It comes out every month here at NCI. There's a website that you can go to. If you search for State of the Climate, you'll get access to the data. And there's not only at county level, but you can go down the census tract level. As for the socioeconomic data, that's from the Census Bureau, and they also have a pretty snazzy website where you can get all of their data for the 2020 census and other censuses and the American Community Survey as well. So all that data is publicly available.
Thank you. And maybe if you have a moment, would you mind popping that information into the chat?
I can do that, yes.
Thank you so much. And thank you for your response. We have another question. What partnerships do you have with the public health community? And maybe I will,
Yeah, I was going to say I can take that one. At least from the National Weather Service perspective, we are working with CDC, HHS, which is of course CDC is under the Health and Human Services at the federal level, and that is part of the Extreme Heat Interagency Working Group as well as NIHHIS. But then at the state and local levels, our regional offices within the National Weather Service, as well as our local forecast offices, work with their state and local public health officials. So that usually is state health departments and can go down to the levels of individual hospital networks.
Thanks so much, Kim. So that'll be our last question for this first group of panelists. Thank you so much for all the great questions. And there's another question that we can possibly address later in the webinar today. Kelly, back over to you.
Thank you, Nicole. Good questions. Remember, you can type your question in the questions pane of the GoToWebinar control panel. Our next speaker is Hunter Jones. He serves as the Extreme Heat Risk Initiative Program Manager in NOAA's Climate Program Office and is one of the architects of the National Integrated Heat Health Information System. He leads NOAA's citizen science urban heat island mapping campaigns, as well as an urban climate research program, both focused on helping communities build equitable resilience to extreme heat. Tell us more about the heat mapping campaigns, Hunter.
Thank you, Kelly. The Washington, D.C. cityscape in this photo is beset with environmental and social forces that could determine whether the residents here will live or die this summer. And if that sounds extreme to you, consider this. Thousands of heat-related deaths occur in this country every year, with urban residents, particularly those who are Black, experiencing the highest death rates due to heat. Cities are hotter because of the urban heat island effect. Notice the dark rooftops that absorb the sun's intense heat. In the center, notice the unshaded street lacking vegetation that could have otherwise lowered temperatures through evapotranspiration. Notice the cars, which, when running, pump waste heat into the environment. To get an impression of what a difference these things make, look at the infrared images of the tree in the basketball court in the bottom center of the slide. A shady tree is reading 84 Fahrenheit, while an unshaded basketball court is 125 degrees. These measurements are of surface temperature, which is only one aspect of the heat humans feel, but it is very clear how shading and materials can affect temperature. These are the forces that cause the urban heat island effect, the ones you can see anyway, but also consider the social forces at play. For several decades in the 20th century, racist home loan and insurance policies clearly defined which neighborhoods were considered desirable and which were considered hazardous, thus dictating which neighborhoods and homes would receive investment in things like greenery and home energy improvements. These investments, or the lack thereof, can cause some neighborhoods to be 20 degrees Fahrenheit hotter than others, meaning some are uncomfortably warm while others are deadly hot. In order to address these inequities, people need to be able to see them, and that is why since 2017, NOAA has been working with CAPA strategies and communities across the country to map urban heat islands. As you can see in the lower left, citizen scientists attach sensors to their cars and bikes to collect on-the-ground data in their own neighborhoods. These observations are melded with satellite data using machine learning to create urban air temperature and heat index maps, such as the one of northern Manhattan and the Bronx, shown in the lower right corner of the screen. Just to the left of the heat map, you can also see an environmental justice map highlighting disadvantaged communities in gray. Notice how well the temperatures on the right line up with the vulnerable communities on the left. Suddenly, these forces are quite apparent. Fortunately, there's much that can be done to mitigate urban heat. Take a look at the photo of DC again, but this time notice the bright white roof on the right, the solar panels in the center, the mature trees in the back and on the right side. That's how we fix the environmental forces causing cities to be hotter. And there are policy fixes for the social issues too. The cities and counties we work with are striving to ensure heat-safe housing for all. That means making sure everybody has a home to live in, that those homes are energy efficient, that they have access to cooling solutions like heat pumps, and that they can afford the energy needed to run them. Thanks to solutions like these, it is my hope that a decade from now, even in the face of climate change and rising temperatures, nobody will have to die from exposure to extreme heat. Thank you.
Thank you, Hunter. Speaking of warm cities, we're now going to switch our attention to Phoenix, where Paul Inyagith is a Science and Operations Officer at the NOAA National Weather Service Forecast Office. Of his now 20-year career, Paul has spent a combined 13 years in Phoenix. He leads the office's extensive heat program and is one of the primary developers of the Heat Risk Project. Originally from Minnesota, Paul has personally experienced extreme temperatures ranging from minus 30 degrees Fahrenheit to 120 degrees Fahrenheit, of which he'll be talking about the higher end today. Paul is actually on vacation in Colorado and is graciously joining us by phone, so you won't see him. Welcome, Paul.
Thank you for the introduction. I'll speak to the slide and each of the numbered inset images sequentially, moving roughly clockwise from the top left. So everyone knows Phoenix is a hot place. It's America's hottest large city. Image number 1 shows an example of how heat is ingrained in the culture. A sign at the head of a popular trail within the city of Phoenix warns of the danger. In fact, beginning this year, the city of Phoenix closes popular trails when the NWS issues an excessive heat warning. Unfortunately, the heat is getting worse. Image number 2 depicts temperature trends during the warmer months of the year across the U.S. during the last half century. Across the Southwest, temperatures are increasing as much as half a degree per decade. For large cities, urban heat island effects influence those trends further, especially with overnight temperatures. The impact from the heat is honestly tremendous. Image number 3 shows the headline. In 2020, the hottest warm season on record for Arizona, over 500 heat-associated deaths were recorded by health officials. This doesn't even touch on the lesser impacts: thousands of heat-related injuries, increased energy costs, lost productivity, and reduction in quality of life. What are we at the NOAA NWS Phoenix office doing to help mitigate these impacts of heat? Quite a lot. There's a large community of practitioners, government officials, academia, media, NGOs, and much more that's grown in the last several years to tackle the problem head on. As seen in image number 4, NWS Phoenix co-leads a pre-seasonal preparedness meeting with the State Health Department and Arizona State University. This is followed by a Heat Awareness Week. And then as the heat season unfolds, we provide regular updates to the Arizona Heat Resiliency Group. This year, we're working closely with the City of Phoenix's new Office of Heat Response and Mitigation. A significant contribution we've assisted with is the development, fielding, and promotion of the heat risk product, which you can view for the Western U.S. at the link provided and navigate as demonstrated in image number 5. Heat risk compares our high-resolution forecasts against thresholds derived through climatological data sets and collaborative research with the CDC to convey the risk level posed by heat. It has proven to be a great tool to help us message the dangers of heat, and not just on the hottest of days. Install instructions are available on VLab. We've seen many of our partners adopt heat risk. Media partners are displaying it on air, as seen in image number 6. Health partners are highlighting it in their own briefings. Local governments are incorporating it into their hazard mitigation plans. So adoption is truly taking off. And we know that heat risk works, as shown in image number 7. Emergency room visits due to heat and illness in the Phoenix area, this data was not using the creation of heat risk, that showed a clear stepwise function when averaged by heat risk level in 2020. If you have further questions, I'd be happy to chat about that. Thank you.
Thank you, Paul. Heat risk is really a great tool. As we've already heard, NOAA is committed to building equitable resilience to extreme heat, and our next presenter will tell us more about current projects to address this. You've already met Nicole in the question sessions. Nicole Fernandez is serving as the acting NOAA West Regional Coordinator as one of her rotational assignments for Cohort 12 of NOAA's Leadership Competencies Development Program. For the past several months, she has co-led the climate and equity project she will be discussing. Today, she is filling in for Asia Shumalo, who set the foundation for this project and is normally the NOAA West Regional Coordinator, but is also on a rotational LCDP assignment. In her usual position, Nicole is a policy analyst within the National Ocean Services Policy and Constituent Affairs Division. Nicole?
Thank you, Kelly. NOAA Regional Collaboration is a network of employees across NOAA, connecting our work to improve NOAA's service to the nation. 8 regional teams work together to find ways for all parts of NOAA to address challenges by connecting people and places, exchanging both national and regional insight to inform action, and improving understanding and respect for NOAA's mission. Following the President's executive order on advancing racial equity and support for underserved communities through the federal government, all federal agencies are working to evaluate barriers that communities and individuals may face accessing federal programs. One of NOAA's priorities related to this executive order is climate services. The 8 NOAA Regional Collaboration teams held events, climate and equity roundtables, to gather feedback from these community partners on how NOAA supports them addressing climate-related events like flooding, sea level rise, and extreme heat. The roundtables provided critical opportunities for NOAA leadership to hear about the needs of communities who are at higher risk of being impacted by climate-related disasters. Next, NOAA funded pilot projects in each region to respond to key needs expressed in the roundtables. In the Southeast and Southwest, NOAA hosted roundtables on extreme heat with community organizations in Charleston, South Carolina, Miami, Florida, Phoenix, Arizona, and Las Vegas, Nevada. As we've already heard, many people are disproportionately impacted by an extreme heat, like people experiencing homelessness, BIPOC communities, people who have outdoor jobs, and children. People impacted by extreme heat often lack access to shade structures. They may have poorly insulated housing or have inadequate air conditioning. We heard from a range of organizations that NOAA should enhance real-time heat monitoring and messaging to communicate that heat is a natural disaster, explain the steps that people should take to mitigate the effects of extreme heat, create a better understanding of heat health risk under different weather conditions with demographic and geographic considerations so we understand the lived experience of as many community members as possible. And finally, build relationships and trust between the federal government and local communities. For the pilot project, we'll work with partners on the ground to gather and analyze data on urban heat exposure through citizen science activities, host tabletop exercises with local, state, and federal partners where we evaluate an extreme heat disaster scenario in a safe environment, develop a set of recommendations for improved communications and interventions to reduce heat risk for disproportionately impacted populations. And finally, work with partners to implement priority improvements. We've been in constant communication with our community partners to adapt the pilot design to meet their needs. This entire effort is part of a larger NOAA strategy to make equity central to NOAA's mission. This project truly is a cross-line endeavor with involvement from OAR, the National Weather Service, NIHHIS, and the National Ocean Service. We're hoping these pilots can be a bridge for long-term partnerships between NOAA and local communities.
Thank you, Nicole. And thank you for jumping in as Asia was dealing with travel issues. All right, now it's time for me to turn it over to you to ask some questions. We appreciate those who have submitted the questions. And remember, you can type it in the questions panel of the GoToWebinar control panel. Nicole?
Thank you, Kelly. I may need to ask myself some questions. And thank you to Hunter and to Paul. I think you really helped us understand the effects of extreme heat at a more local level, whereas our previous panel focused more on a national level. So here are a few questions coming in. Where can we find urban heat island mapping?
If you go to the NIHHIS website, which is at this moment NIHHIS.cpo.noaa.gov, there should be a map of where we've done the campaigns in the past and where we're doing them this summer. So that's a great place to find what the locations have been and to get the data sets and the reports as well.
Thank you, Hunter. And here's another question. Why is heat risk still experimental when I see that it was first announced in 2017? When will it go from being experimental to fully operational? I think that would be a question for you, Paul.
Yeah, and I wish I could defer to Kim on that also. It is working through the process, and there is a test bed at the Weather Service Operational Proving Ground that's going to be looking at the different tools this summer. I believe the hope is that we can get it going across the country by next year.
Thank you, Paul. Another question we have is the observed on-the-ground observation tools distributed via some sort of public access programs mentioned by Kim or Morgan and Hunter? So I don't know.
I could answer for the urban heat island mapping campaigns at least. We work with a private sector company called Kappa Strategies, and they're the ones who really manage all the equipment that goes out to the communities. So it's sort of loaned to them in a sense to do the mapping campaign. And so they're attaching sensors to their cars that have been developed by Kappa Strategies with additional components. So that's how that is managed, and we run an application process to determine which communities we work in every summer, and that process happens typically in the fall. Around October, we'll have those applications open, and those will also be on the website.
Thanks so much, Hunter. And Paul, did you want to try to address that from your perspective?
No, I think what Hunter had was good.
Okay. Thank you. And I'm going to go back up here because, Paul, you touched on this, but maybe you can provide a bit more detail. How are local news stations being used to help share this information about extreme heat? And maybe you could talk more about the experience you've had in Phoenix.
Yeah, I mean, they message it quite extensively, and I think part of our real challenge that we have is just how long the heat season is and continually conveying the threat. So it's certainly something that the news media will focus on, but it becomes really a challenge later on in the season as well as you get to the 5th and 6th months. It's still something we're actively working on with researchers even trying to figure out the right way to do this.
Thank you. And in my current role, I've learned that the Phoenix Weather Forecast Office also has a strong partnership with 2 Spanish-speaking media outlets, Univision and Telemundo. And those media outlets regularly provide heat messaging in Spanish, and they're currently working on a documentary to really explain the extreme risk of extreme heat. So that should be really informative, and I think help mitigate heat risk within maybe Latino communities in particular there in Phoenix. All right, well, thank you so much, Hunter and Paul. Those were all great questions we received. Thank you for continuing to put questions in the chat. And Kelly, I'll hand it back over to you.
Awesome, thank you, Nicole. We'll now transition to our final group. Have you ever wondered what happens when the ocean has a heat wave? Mike J. Cox is going to tell us. He is a physical oceanographer working at NOAA's Southwest Fisheries Science Center lab in Monterey, California, as well as the Physical Sciences Lab in Boulder, Colorado. His research focuses on ocean variability and change, including extreme events such as marine heat waves and their impacts on marine ecosystems and humans. Recently, he has been leading efforts to improve ocean predictions and explore how these predictions can be used in the management of fisheries and other marine resources. Mike?
All right, thanks very much, Kelly. Yeah, so we will turn our attention now from extreme heat over land to extreme heat in the ocean, and specifically to marine heat waves, which are less well known than heat waves over land, but they are the analogs in the ocean, periods when regions of the oceans are exceptionally warm, and they can last actually for months, even years in some cases. They can be much longer lasting than heat waves over land. And so impacts of these heat waves have become particularly notable in the past decade or so. Things like coral bleaching, changes in the distributions of different marine species, changes in the food availability for marine species, and therefore changes in mortality for things like fish and marine mammals and birds. And then there are knock-on effects to human communities through things like fisheries, like changes in the availability of different species and changes in closures to fisheries and the economic impacts that follow. So given the impacts that are becoming more and more well known of these marine heat waves, there's a desire to predict them, to provide advanced warning for management, similar to how one would for an extreme weather event or a hurricane, or even just, I don't know, the probability that it's going to rain tomorrow. So we have developed forecasts like that using existing climate forecast models for the whole globe. And we've developed a tool where now you can see forecast probabilities of marine heat waves over the globe for the coming year. And so in the upper right panel here, you can see an example of that. This is just a sort of random month. This is a forecast made in June 2020 of 3 months ahead. So what will come 3 months later in September. And you can see areas sort of in the pinks, sort of pinkish orange, where there's a higher likelihood of marine heat waves to come. So an obvious question is, how good are these forecasts? And that's what the figure in the lower right is showing. This is an evaluation of forecast accuracy that was made using 30 years of retrospective forecasts. And basically the areas of the globe that are more red are where we can predict marine heat waves with more skill. And this is, for an example, this is looking 3 months ahead. So you can see regions, especially in the Eastern Pacific Ocean and in the tropics in general, where it's quite red, means we can predict these with high skill. And the US West Coast jumps out as a region of really high predictability and good opportunity to predict these events in advance. At shorter lead times, 1 month ahead, you get higher skill, and at longer lead times, you tend to get lower skill. So we're excited about this as a new tool in the toolbox of marine management. You can see forecasts online at the link in the lower left. And I'm certainly happy to chat about them more. Thanks.
Thanks, Mike. Thanks for sharing this new tool. You've probably heard coral reefs are one of the Earth's most diverse ecosystems. But what happens when they're threatened? And how does this relate to extreme heat? Our next speaker will answer these questions. Derek Manzello is coordinator of NOAA's Coral Reef Watch program, an effort focused on the monitoring of coral reef ecosystems through satellite and in situ observations. Derek has published on multiple topics in coral reef ecology, and he regularly conducts research that spans the disciplines of biology, chemistry, and geology. His primary research interest is understanding the impact of climate change and ocean acidification to coral reef ecosystems. Derek?
Thank you. Many of you have probably heard of coral bleaching, but less of you probably know what a global coral bleaching event looks like. So from 2014 to 2017, the world experienced its third global coral bleaching event. This animated figure shows you the heat stress rolling through the global ocean 3 times during the event. This was the largest, most widespread, and most damaging event on record. More than 75% of the world's coral reefs suffered bleaching level heat stress, and more than half of the world's reefs bleached 2 or more times during this one event. Now, corals harbor symbiotic algae that provide up to 95% of their nutritional requirements. When heat stressed, the corals expel the algal symbionts and turn white. When a coral is bleached, it is still alive, but it is in a state of slow starvation. If the heat stress persists, the coral will die, but if temperatures cool off, the corals can recover. One of the first places to bleach during the 2014 global bleaching event was the Florida Keys in September 2014. Now, this coral in this picture is listed as threatened under the Endangered Species Act, and for scale, it's about as tall as I am, about 6 feet tall, or roughly 2 meters. Now, this coral grows 1 centimeter per year, so this coral in this picture is at least 200 years old. In April 2015, the Chagos Archipelago in the Indian Ocean, which is one of the most remote reef regions on the planet, experienced bleaching. Here's a picture of some acroporid corals just starting to bleach in the bottom left-hand corner. Unfortunately, most of the corals in this picture died as a result of this event. Now, coral reefs are biodiversity hotspots and often called the rainforests of the sea. Now, approximately 25% of all marine species associate with coral reefs at some point in their lives. So when a coral reef experiences bleaching and coral mortality, this has downstream impacts to the high biodiversity that is found on coral reefs. This next picture of this yellow little fish is a guinea fowl pufferfish swimming amidst a field of bleached corals in the Indian Ocean. Now, this guy is called an obligate corallivore. Now, that is a fancy way of saying that he feeds on coral and needs to eat live coral for his survival. So as the coral dies, he will likely starve. Now, corals are not the only thing that bleach. Clownfish anemones harbor algal symbionts just like corals. Many of you probably know that clownfish use these anemones to escape predators, thanks to the movie Finding Nemo. So when the anemone bleaches and dies, the clownfish will likely then be eaten by fish. So this is very bad for many different types of species on coral reefs. So as a result of the coral climate crisis, NOAA is now investing resources into restoration of key reef areas. This picture shows you endangered staghorn corals being grown on a tree. Once these corals get big enough, they are planted on reefs that have been impacted by coral bleaching. So coral managers and scientists are thus actively trying to restore reefs that have been degraded by rising ocean temperatures. Thank you.
Thank you, Derek. Last summer was one for the record books in the Northwest United States. Our final speaker will tell us more about the impacts on Washington's shellfish. Terry King is an aquaculture and marine water quality specialist for Washington Sea Grant. Stationed in South Puget Sound for the past 30 years, she is quickly accessible to the heart of shellfish resources in the state of Washington. She engages stakeholders in a variety of issues, including shellfish safety and aquaculture and harmful algal bloom research and monitoring. You can find her out on the tides and in the hatcheries providing technical assistance to aquaculture producers and seafood harvesters. Terry.
Thank you, Kelly, and thanks to the presenters in this session earlier for bringing it to the animals and to the things that I love in the sea. The third week of June in 2021, we did have we were alerted by Reed and his team up at the NOAA National Weather Service office in Seattle that we were going to have heat. And so what we did was the shellfish producers took note. started to prepare. We do have heat and other best management practices that we use, but unfortunately this heat was occurring at the same time that we were experiencing the lowest tides of the year. And this is due to the lunar nodal cycle. And as you see in this graph, the water level was really, really low, the lowest we'd seen in 12 years. At the same time, the temperature was the highest we'd ever seen. And so that was not a good combination. Growers prepared. They practiced best management practices with not only their staff, the workers on the farms and in the processing facilities. They shifted their processing so that they were off heat hours so that they could ensure seafood safety, which was really important. Washington is the leader of farmed bivalve shellfish in the US. They use shade cloths, sprinklers, other techniques that we use to reduce naturally occurring bacteria that love the heat. But that wasn't enough. We, despite all of the best efforts, some of the clams came to the surface. One of the responses to clams that are stressed is that they'll come out of the substrate onto the surface. It could be a biotoxin, or it could be heat or something else. So they came up. The oysters were just, being normal, but they succumbed as well. The first animals we saw perishing were cockles, followed by our mussels, both on rafts and on the beaches. We found clams, a variety of different sizes and species. Geoduck clams that were juveniles were also struggling. Oysters, as I mentioned, all of our species, and then also barnacles. And barnacles are really hardy, and so that was very unusual. It told us that we had a lot of heat. So we did have we did have those animals die, but not everybody died. There were some locations where we did not have complete mortality. In those areas, what a natural response is for animals is to spawn, and boy did they. They spawned, they released egg and sperm into the wild as broadcast spawners, and we are seeing evidence of that spawn this year as we've gone out onto the tidelands. Last week was our most recent lowest tide series of the year, and so we were able to see that. But about 60 to 80 of our shellfish companies, and we have about 230 here in Washington that actively produce both tribal and non-tribal commercial facilities, experienced dramatic losses that could be helped by a USDA program. Now, what's very fortunate about this USDA program, it's called ELAP, which is the Emergency Assistance for Livestock, Honeybees, and Farm-Raised Fish. Well, as of June 1st of 2021, it also included shellfish aquaculture. So many of our producers, a few of our producers were able to go in and apply for this really important resource. So we had the warnings, we took precautions, but still the weather was just too much. And unfortunately, with the lunar nodal cycle and the heat waves that we've been discussing today, we anticipate this to continue on, and we're looking for more resiliency. Thank you.
Thank you, Terry. Especially thank you for sharing this information about this heat event. It's now time for questions for these last three presenters. What questions do you have, Nicole?
Thank you, Kelly. These presentations were so informative, especially in the marine environment, despite the horrible conditions in the Pacific Northwest last summer. The first question is, why is it easier to predict marine heat waves in the Pacific than the Atlantic? I assume that question might be for you, Mike.
Yeah, it's a good question. So the main thing that drives the predictability is sort of how quickly the ocean evolves and then how reliably it responds to sort of large scale changes in the climate. So the main reason in the Pacific is that we have ENSO, or the El Nino Southern Oscillation, which is this dominant signal in the Earth's atmosphere, in the Earth's climate. We have El Nino and La Nina events that periodically come through and have large impacts on the ocean temperature. So they provide this big predictability signal in the Pacific, and the Atlantic just doesn't have that same kind of climate signal that drives predictable changes in the temperatures.
Thank you. And another related question about forecasts, that is how might these forecasts that you mentioned be used in some of the ways that you already mentioned, but beyond those ways? So what are some other ways these forecasts can be used?
Yeah, right. So broadly, the idea is to increase lead time for decisions by ocean managers. So I think a lot about fisheries. In fisheries, there's things like trying to adapt to changes in population. So you might adjust the harvest guidelines, like how many fish can be caught, depending on how you think the population might be impacted. Or you might alter the timing of a season so that you don't have interactions between fishing gear and protected species like whales. So things like entanglement in fishing gear can be a problem associated with these heat waves. You might be able to mitigate some of those kind of issues.
Thank you. And this next question is for you, Derek. Do bleached corals always die? And if so, can they recover?
Bleached corals don't always die. So when the coral bleaches, it's losing its symbiotic algae. So that those algae provide, as I mentioned, about up to 95% of the nutritional requirements of the coral animal. So if a coral bleaches and it loses these algae, it's essentially going through a period of slow starvation. So if the heat stress declines quickly enough, then the coral can start recovering the symbiotic algae, and that'll help it survive. And another mechanism that corals use is corals actually also feed from the water column. So they feed on plankton and zooplankton out of the water column. So corals that are better able to feed on additional resources are generally better able to survive coral bleaching events. But what it really comes down to is the magnitude and the duration of the heat anomaly. The hotter and longer it lasts, then the more detrimental and the more likely that you'll see coral mortality. But the key point is, when a coral first bleaches, it's still alive for at least a few months, unless there's extreme heat stress. In some cases, there's been examples of extreme heat stress, like on the Great Barrier Reef, where corals actually didn't even bleach. They went from healthy to just completely dying immediately because it got so hot so fast. So again, it really comes down to the magnitude and the duration of the heat stress anomaly.
Thank you. I didn't realize that they survived, at least for some time, when they were bleached. So thank you for that. All of these presentations have been so great. We now have time for a few more questions, and we'd like to open it up to all of the panelists, and we invite them to please turn on your cameras. And for those who are watching or participating, please feel free to continue dropping questions in the chat. Here's another question, and this sounds like a coral reef question too. It's just more of, I guess, a comment. It's not really a question, but just interesting to see how connected the marine life and coral reefs are. The lighter colored, less vibrant coral reefs are influenced by lighter colored marine life. So just those interactions at the ecosystem level. This is a question about kind of optimism. How do you maintain a sense of hope and optimism when it seems like there are many challenges over land and sea with extreme heat, which will likely keep increasing? Who would like to take that existential question?
I'll take it. We don't have a choice. We have to just try and be optimistic. I am fortunate to work with industry members who understand the value of not only the products that they're producing, but also the ecosystem services that they're producing for our environment. And they're going to figure out a way with all of these brilliant people on this screen and others to figure out how to do this. I mean, Mike's telling us when the heat waves are is critical so that we know when to be able to pull in our water for our hatcheries. And if we can link that to our harmful algal bloom forecasting, that will help us even more. So just working together, we can't be pessimistic about this. We've got to figure out a way. And everybody's counting on all of us to figure it out and to work with them.
And what makes me optimistic is working on these citizen science projects, working with communities. I see how charged up they are about this, and it makes me very optimistic that we will address this. We will solve this problem.
And I'll just add on to that people are starting to really understand that heat is a problem and taking it seriously. And we see that all the way from the administration forming the White House Extreme Heat Interagency Working Group. And my work with that and NIHHIS has really shown me there's a lot of resources and energy and real heart for the people working on these problems. We just need to make sure that we're reaching out and collaborating and like Terry said, she gets her information from Mike. Well, we need to make sure that everybody is aware where they can get the right information and be able to work more efficiently. So keeping those lines of communication and collaboration open.
Yeah, well said. And it's a nice message of hope. I was going to ask you all a question on how you all collaborate because I have a taste of it in this role, but Kim, you did a nice job of touching on that, and Terry as well. Terry, we have a question from you for you in the chat. Can you say more on animals coming to the surface?
So one of the stress responses in bivalve species that are burrowed into the sediment is physically coming out of the substrate. It's just a well-documented, well-known artifact of their stress response. And so you will see that they will do it under heat conditions. They will sometimes do it under low dissolved oxygen conditions. They will also do it during toxin conditions. So a recent toxin that we identified, yezotoxin, that has been killing large numbers of our farm bivalves here in Washington State. When those clams surfaced, we were able to identify great levels, the highest levels, unfortunately, seen in the U.S. in those species, and that is it's just one of those things. And we do have a paper, and hopefully somebody can pop it in. It just came out earlier this week, talking about all of these factors with the intertidal bivalves throughout the Salish Sea and what we experienced in June of 2021.
Thank you, Terry. And this is a good follow-on question, and this one is for Mike. How does your heat forecasting fit into the harmful algal bloom forecasting mapping, of which NOAA helps lead? I added that last part about other NOAA involvement.
Yeah, I think that there are certainly suggestive links between extreme warming and harmful algal blooms. In 2015, during this huge marine heat wave, we had this unprecedented coast-wide harmful algal bloom along the West Coast that had all kinds of ecological and economic impacts. So, in theory, this could extend the lead time for those kind of events. I think there's a lot of work yet to be done to really understand the drivers of harmful algal blooms. I don't think that you can say every time there's heat wave, there's going to be a big toxic event of that nature. But yeah, I think it helps us move in that direction of better lead time for preparing for those types of events.
Thank you. It's been so helpful to learn about all these connections. And these have been all such great questions. I know I've learned so much about this topic, which has become even more salient to me through my current detail position. And Kelly, I'll hand it back over to you.
Thank you, Nicole. I know you have to rush to another gathering, another meeting. This has been such an interesting webinar. Thank you to all of our wonderful panelists today and coordinators Nicole Fernandez and Bethany Perry, as well as you, our audience. I hope you've learned something new, as I have. If we didn't get to your question, we will pass it along to our panelists, so don't worry. As we end, please stay on for one more minute to answer a few brief questions that will appear on your screen. Your feedback really is helpful as we plan future webinars like this one. And I hope you will join us for our next webinar, which we will be focusing on drought. If you are interested in checking out past webinars and to find information about future webinars, visit our website, www.noaa.gov/Central Region, where you'll also find more great information. Thank you again for your participation and have a fine day. Bye.